Okay, so now what we need to do is we need to now create some sort of join so that we get these tables back into this census tract layer. So we're going to do this in traditional table join fashion way. We're going to go to joins and relates. We're going to add our join. We are going to make sure that we have the FIPS in this case, and then we are going to do the zonal statistics, right? Should auto-populate to the FIPS. If it doesn't, definitely double check and make sure that you have some sort of code that looks the same. And then we go down, make sure that we have some sort of thing. In this case, we've got 15,000 records. That's the same as the join table. It is not all of the 16,000. That's okay. It is close enough. So we are going to do that. We are going to repeat this process for each of them. Now, if you want to go in and you want to double check that it's doing it correctly, definitely do that. Now, what you'll see here is that all of a sudden your FIPS now has this backend attached to it. This is a good thing. This is just telling you which original table it was in, because we have multiple with FIPS. So we also have the zonal statistics, FIPS. Just keep going with the census tract, FIPS, and again, just keep going in your alphabetical order. It will probably make your life easier. Now, it's going to tell you that it has invalid characters. That is fine. It should still join if you have the newest arc. Sometimes it does get a little grumpy, and if that is the case, all you will do in that case is you'll go to data, export features every single time after you join the data. But for the most part, it should continue to do that. It should still be fine, even though it does have that issue in the meantime. And so you just want to make sure that it has each one of those. So you're using that zonal statistics table to join this back, right? And so we can close that and okay. And so now if I open up this attribute table, I should, if I go all the way over, I now have this mean over here. This is for the last one, the Cetatiformes. This one's for the Passeriformes, and this one is for the Gruiformes, right? So I can double click this to sort it, double click it again to sort it the other way, or right click and sort it. And now this top one here, so this one here, this one is the one that has the highest for the Gruiformes. This makes sense. This is right over top of where that value actually is. Now, in my case, because I don't like virtual joins, generally speaking, I'm going to go back here, I'm going to clear my selection, and then I'm going to export these features into a new join data set, just because this will hard code those joins in. So sometimes ARC gets a little bit grumpy about what it has for joins. Sometimes those virtual joins, they break, they get unhappy. I don't really like dealing with that. So because of that, I'm just going to do what I just did, which is right click on those features, go to features, export data, export features, and this is going to hard code those in together. So from here, what I'm going to do is I'm going to create a ranking system. So to create this ranking system, the first thing I need to do is I need to add a field. So I'm going to go to add field, I'm going to call it ranking, and I am going to call it a double, okay? So I'm going to do this, I'm going to X out of it, I'm going to save that. If I go over to the far side of it, it is going to have this ranking that is a null. Now before I do this, one of the things I need to make sure of for this ranking system is that I want to only have these census tracts that have all three of these different orders in them, right? So I only want the things that have all three orders. So to do that, I'm going to go to select by attributes. I'm going to find where, you'll notice that this gets a little hard, so just make sure that you know what things are what. I'm going to go to my first one, and I'm going to say where mean is greater than 0, and where my next mean is greater than 0, so not the top one, right, keep it in alphabetical order, is greater than 0, and my final one is bottom mean is greater than 0. Now, what this is doing is it is only pulling out the attributes, or in this case, the census tracts, right? There's not that many of them. It is only pulling out the census tracts where these are in fact greater than 0. So you only have a certain number of census tracts that have all three of these values. And you can double check it, right? So if I click on this button down at the bottom left here, I can click on it and I can double check that in fact each one of those is greater than 0, right? So I can go and this one is 0.0003. I can go to my next one. This one is actually 0, which I'm not happy about. It probably is some variety of 0.001, honestly. And then I go to my final one here, and it is this 0.002. So it looks like there might be one of these that kind of snuck in that is some order of magnitude above 0 that is not great. And so, but it only is that one value there. So we're going to say that that's fine. And now this one, I'm going to right click on this, right? So I'm going to, this is, again, this census one track to join. I'm going to right click on data, export these features, and these ones are the census tract ranking counties or ranking tracks. Census ranking tracks. So it's only those counties that I'm actually going to rank because I want to make sure that there are in fact all three of those orders in the ones that I want to rank, right? So this drops it down fairly substantially, right? So this no longer looks like I have the entire Southeast that I can do. Really, I only have a couple of different areas. And so from here, what I'm going to do next is I'm going to open up that new ranking table. So I'm going to go to my attribute tables, I'm going to go to it, I'm going to go over to my ranking, which is here now. So it's done the shape and area on the far side, but now we've got this ranking. I'm going to right click on that ranking and I'm going to go to calculate field. Calculate field works a little bit different than calculate geometry in that you have to put in some sort of formula. So not all that dissimilar to how we could work with Excel, but I have to put in my formula. Now, one of the things I will say with this is it is always better to double click the things that you want versus trying to type it in because this particular thing is very, very, very picky. So I'm going to scroll down and I'm going to do the same thing here. So I'm going to go to mean, I'm going to double click on it, I'm going to then add it over. I'm going to keep scrolling down. I'm going to double click my next mean. So this is the Grumifores. This is the Passeriformes. If you have been doing it in alphabetical order, this should also apply for yours. And then I'm going to double click the last one. Now you will notice that in the actual mean coding, these look different. These should look different, right? So these are not the same back end one. They look the same, but they're not actually the same value. And then I'm going to divide this by 3. Now, if you know anything about statistics, what you will see is that I am taking the average density of these things. So I'm going to take the average density combined of this. So I have the highest average density of all of these different things. And so the highest average density of all of these different orders, that is how we are going to rank them. But we wanted to make sure that we do this using only the counties that have all three, right? Because otherwise we could maybe have some weirdly high one, maybe back in that Hope Beach, right? Where it had a lot of one species. We don't want that. We want highest where it still contains all the species. So this is a 2-part ranking system. From there, we hit OK. It's going to calculate this field. We are going to go over. Magically, we have these values. We go from 0.1 all the way up to 92,333. So if I look at this one is this tiny one down at the bottom here, right? So it's this tiny one down at the bottom. This one has the highest total average density of sightings for this. And you can see that in this particular case, it has one really, really high density one over here. Now, if we were going to get into it, then we could add more things onto this, right? So yes, there's a lot of density here, but maybe I don't want something in urban. This is a future us problem. We will do that in another week. We will add on some other things like elevation and land cover type to further rank these out. But for now, we just want those ranking things. So now what you're going to do is you are going to go to your symbology. make sure you change the symbology to your graduated colors, come up with that ranking system, create a map, make sure it has a useful title and all of that. And for example, if you were to look at the one that I created here, it would have something like this. So each one of these census tracts, you'll notice, right? So we had the highest census tracts over here, and this is how we do the things. So this is how we created that ranking to figure out where is going to have some sort of high and or low density of all of these different things. I can then take that to some sort of body that deals with policy and say, these are the areas where you want to protect. I would want to protect the areas with high density more. Again, we can subdivide these out in the next ones to be like, okay, but I also want to make sure that it's not just these birds. I want to make sure that it's outside of an urban area that also has this. That we will do next time round. But for this would be your ranking based solely on where these birds exist. So that's what we got. Hopefully this made it a little bit easier to follow along with, and I will see you back here next week. Thank you so much.